Hi everybody. In this video, we are going to discuss about broadcast application concepts. So this is completely, we are going to discuss about what is broadcast. So how the broadcast will be used, what are the advantages, disadvantages of broadcasting. So in IPv4 network, how the broadcasting is going to take place. In IPv6, there is no broadcasting, but instead of broadcasting, what are the things they are using? So these are the different things we are going to discuss in this particular video. Now, so the basic content, what we are going to discuss here is what are the different types of address available, unicast versus broadcast example, then broadcast issues in programming. So this is the overall thing that we are going to cover in this particular video. Now, I'm moving on to the introduction part. So we already know what is a broadcast. Okay, so broadcasting means it is one to all. That means from one PC or one host is going to send the data. All the hosts in the network or in the subnet, they will receive the data. So this is called broadcasting. So in simple term, we can say it is one to all in a very simple term. Now, we are having multicast also. We are going to discuss multicasting in the next lecture. So generally what is multicasting means? It is going to be one to many. Okay, so one to many. So not all in a network. So a group of people or group of hosts or the group of interested hosts, we can say. So they are going to receive the data. So this is the basic difference between multicast and broadcast. Now, both the broadcast and multicast concepts are completely based on UDP protocol. Okay, so we already know about UDP protocol, user datagram protocol, so which is an unreliable protocol. So based on UDP only, so the broadcast and multicast is going to work. Now, so we are going to have a very quick recap on datagrams. That means what is a datagram, so basic things. Then how it is implemented in Java. That means how the broadcasting concept will be implemented in Java, we are going to discuss. Then we are going to discuss about the disadvantages of broadcasting, and also we are going to discuss about multicasting. That means instead of broadcasting, now it is proposed multicasting. That means in IPv6, multicasting is going to play a major role. So we are going to discuss about the multicasting also few slides. So this is a small introduction. Now I'm moving on to the next slide, datagram recap. So what is a datagram? So generally what is a datagram? So a datagram is an independent, self-contained message sent over the network. So over a network, we are going to send a message. So it is a self-contained, everything will be available like source IP address, destination IP address. So everything will be available in that message, with that message, and it is completely independent, whose arrival time and content are not guaranteed. So this is very, very important. So the arrival, whether it may reach or not, there is no guarantee. Arrival time, okay, so whether it is going to take 10 minutes, 5 minutes, okay, we don't know, okay, the time we are not going to guarantee here. Then the content also we are not going to guarantee. So this is UDP. So user datagram protocol, it is completely a unreliable protocol. Then if you go for the Java, in Java, so you can create your own UDP sockets you can create. So if you see java.net, so this is the package, okay, which is available in the Java. We can use this for doing the network programming, that means socket programming. So there are two different classes available here, datagram packet and datagram socket. So in lecture number 1 and 2, the first two lectures we discussed about this, okay, how to create a datagram packet, how to create a socket, datagram socket, that means UDP socket. So all these things we already discussed. So datagram packet, so this is one of the class which is used to create a datagram packet. So datagram socket is a class used to create a datagram socket. Okay, so we can use these two different classes, okay, so in Java for creating the UDP sockets. Then UDP is typically used in scenarios where lower latency is more important than the guaranteed delivery. So I want to send the data very fast, very quick, that is a lower latency. So the data must reach the destination very quick, but I'm not going to worry about the delivery. That means that means no guarantee the packet will reach or not. Okay, the datagram will reach or not. Okay, there is no guarantee for that, but I want to do it very quick. So in that applications, okay, for example, audio, video streaming, network discovery. So network discovery means you can have a lot of protocols like DHCP. So plenty of protocols it is going to use, okay, the UDP concepts. Okay, so UDP protocol, it is almost suitable for the application where the data should be delivered very fast. Okay, we are going to deliver the data very fast, whereas we are not going to guarantee the data will be delivered. But if you go for TCP, it will be opposite. Okay, here it will take some time, latency will be there, but the data will be guaranteed. Okay, 100% the data will be delivered to the destination. Suppose if it is not delivered, we are going for the retransmission. Okay, that is in the TCP. So this is just a small introduction about the datagram. Now, moving on to the next slide, address types. If you take address types, there are 4 different types of addresses available. So the first one is a unicast address, second anycast address, third one is a broadcast address, and fourth one is a multicast address. So these are the 4 different types available. So unicast is going to be like 1-to-1. So identifies a single IP interface. So only one interface will be identified. The data will be delivered only to that particular interface. So if you are going for anycast, okay, I'll go for broadcast, then I'll come to anycast. So easily you will understand. So if you're going for the broadcast, okay, all the IP interfaces, that means all the nodes on a network or all the nodes on a subnetwork, okay, it will be identified, the data will be delivered. Then the next one, anycast. So anycast means it is going to identify the best nearest IP address. So here also there will be a group of people will be, group of hosts will be available, but whereas the data will be delivered only to the nearest host. So the nearest host will deliver to all. Okay, so that is a anycast address. So multicast, set of IP interfaces on the subnet, a set. Okay, I'm using the word set, we are not using the word all. So if you use the word all, okay, it will be the broadcast. So a set of IP interfaces, that means the interfaces, those who joined in that group, those who are interested in that particular packet, so that is going to be the multicast. So these are the 4 different types of addresses available. So we are going to discuss about each and everything in detail. Now I'm going for the first one. Moving on to unicast. So in unicast, okay, you can see the diagram. So one sender, that means a single source, and one destination will be there. So this is, we are going to say 1-to-1. So one sender, the source is going to be 1, the destination is going to be 1, so it is going to be a 1-to-1 communication. So TCP works only with the unicast. TCP protocol, a layer 4 protocol, okay, transmission control protocol, it is going to work only with the unicast addresses. If you take UDP, same layer 4 protocol, UDP protocol, user datagram protocol. So it is going to support, it supports broadcasting and multicasting, so which we are going to discuss in the coming slides. So what is the concept here? So in unicast, 1-to-1, okay, a single source and a single destination will be available. Now moving on to the next one, anycast. So anycast, 1-to-many, in that one, so we can say 1-to-1 of many, okay, that is a concept. So 1-to-1 of many, okay, so this 1-to-many is going to be the multicast. So in that the data will be delivered to the nearest person, to the nearest host, so that is going to be 1-to-1 of many communication. So packets addressed to the anycast addresses are delivered to a single interface. So only one interface, okay, the datagram will be delivered. So which interface means the interface which is very nearest, okay, identified the address. So I am in a class, so 40 students are in my class. I have 40 sheets, some worksheets I have with me. So I want to distribute to all. So if I distribute to all the students individually, it is going to be broadcast. So what I am doing means I am going to call one student, okay, who is sitting very near to me. So please come here. So take this worksheets, distribute it to all, I am telling. So this is I am going to have a unicast concept. So identify the nearest host. So deliver it to the nearest host. So the nearest host will give it to the remaining, okay, the host in that particular set. So the nearest interface is defined as being the closest in terms of the routing distance. So how we are going to decide the nearest one means based on the routing concept. Okay, it can be a cost or it can be the hops, number of hops. So based on any routing concept, so the nearest host will be decided. So the nearest host is going to distribute the datagram to all. Okay, so this is the Unicast concept. At present, Unicast addresses are used only as a destination addresses and are assigned only to the routers. So at present, okay, if you see the current scenarios, so only the routers they are using this. Okay, so Unicast concepts are used only among the routers, so to exchange some information or routing informations like that. So Unicast addressing is only supported in IPv6. Actually, IPv6 completely broadcast has been removed. Okay, so Unicast is used completely in IPv6. Okay, so this is about the Unicast. Now I am moving to the next one. The next one is a multicast. So it's very simple, one to a set or one to many. So the people or the host, those who are participating in that particular group, in the multicast group. In the next lecture, okay, in multicasting we are going to discuss about it. Now you can see, so there are so many hosts available here. Okay, host A, B, C, D, E and N. So these are the different hosts available in this network. But only a particular group of hosts, they are joining a group, they are making a group. Okay, so this host is not participating in this multicast group. So now I am going to say this is a multicast group. Now whoever sending, for example, if you take host A is sending a data means only the host in this particular group, okay, they are going to receive. So the one who is not in this group, okay, they are not going to receive the datagram. So this is about the multicast. Now moving on to the next one, the last concept is broadcasting. So broadcasting means one to all. So everybody, whether you like it or not, whether the host needs that datagram or not, okay, it doesn't matter. So every host in the network, it is going to receive that particular packet. So packet or datagram, so that is going to be the broadcast concept. So you can see here, so host A, B, C, N. So any one is going to send the datagram, all the others they are going to receive it. Okay, whether it is willing or not, whether it is liking or not, so they have to take it. So this is going to be the broadcast. So broadcast is having advantages and also disadvantages. We are going to see it later in the coming slides. We are going to discuss it. So depending upon the application, in some place it is having advantages, in some places, okay, disadvantages is available, but more disadvantages. That is the reason broadcast has been completely removed in IPv6. So instead of broadcasting, Unicast is used. Now I am going for the next one. You can see there is a comparison table here. So this is what we already studied in the last 3-4 slides. Okay, so different forms of addressing. Okay, types we are taking here: unicast, unicast, multicast, broadcast. So IPv4 supports. Okay, IPv4 supports unicast. Okay, unicast is available in IPv4, but it is not implemented. It is not used. Okay, completely. So multicast is also available. Okay, you know about class D IP address. Okay, class D IP address, it is completely used for multicast concepts only, and broadcast we have. So if you are going for IPv6, in IPv6 broadcasting completely removed. So we have unicast, unicast and multicast only. So these are the three things. So completely the broadcasting has been removed. Then, so TCP, UDP. So TCP is supporting the unicast. Okay, so TCP is not supporting the unicast. UDP protocol, it supports all the four. You can do unicast, unicast, multicast, broadcast. Okay, you can do by using UDP. Then the number of interfaces identified, the number of interfaces delivered to. So that means the destination. Okay, we are going to talk about the destination. So here one destination will be identified, the data will be given or the data will be delivered to that particular interface. So this is the unicast. So if you take broadcast, all all the interfaces, all the hosts will be identified. The data will be delivered to all. Then multicast means a set, a group of interfaces will be identified. So the data will be delivered to all in that particular set. But whereas in the application, in the Unicast, you can see, okay, so that means a set of interfaces will be identified, but the data will be delivered only one in that set. Okay, so this is the Unicast. So this is what we discussed in the last 4 slides. This is going to be a comparison, okay, a comparison of all the 4. IPv6 added Unicasting to the addressing structure. An IPv4 version of Unicasting which is never widely deployed. Actually, in IPv4 also, okay, the concept is available. Okay, that means Unicast concept is available, but it is never deployed. It is not used actually. Now, broadcasting support is provided in IPv6. Is not provided in IPv6. Multicasting is used instead. Broadcasting and multicasting require a datagram transport such as UDP, and they cannot run on TCP. So all these points it is covered in this particular table. So this particular table is very important. Okay, so a lot of information you can find it here. Now I am going to the next one, broadcasting in a broader way. Okay, so broadcasting, okay, the points are repeated. It is one to all. Okay, we already know that. So the intention is sending a datagram to all the nodes, sending the datagram to all the nodes in a network. Then, so unlike in the case of point-to-point communication, we don't have to know the target, the host IP address. So instead, the broadcast IP address is used. So target, that means the destination IP address you no need to know. Okay, so only the source IP address is enough. So the destination IP address, okay, it is going to be a broadcast IP address. So if you give the broadcast IP address, so automatically everyone in that particular network or in the subnet, okay, they are going to receive the packets. So for example, you can see 255, 255, 255, 255. So this is the broadcast IP address. So if I use this broadcast IP address, so automatically all the hosts in a network, okay, it is going, they are going to receive the packets. So what we are understanding here for a broadcast application, so the source IP address is the IP address of a host, but the destination IP address is going to be a broadcast IP address. So you no need to know the IP address of a particular host. Okay, so you can use a broadcast IP address and you can send the datagram. So this is about the broadcasting. So in the next slide, we are going to discuss about the advantages and disadvantages of broadcasting. So advantages. So if you ask me, there are some protocols really, okay, they are using the broadcasting concept very well. Okay, disadvantages is also available. Okay, disadvantages also available, but there are lot of protocols, okay, built or developed by using the UDP concept. Okay, that means by using the broadcasting. Now you can see, so like NTP, network time protocol, routing table, okay, updating the routing tables, okay, broadcasting, then ARP protocol, BOOTP, DHCP. Okay, so there are a lot of protocols, okay, it's built or developed by using the broadcasting concept. Now if you come to the disadvantage, okay, there are disadvantages also available. What is that means? Okay, it is not mentioned here. Let me just I'll explain the other things. So the first disadvantage is, so it will consume the network bandwidth. So unnecessary, okay, if you are doing the broadcasting means automatically your network bandwidth will be consumed. This is the first problem. The second issue in broadcasting is everybody is going to, that means every host is going to receive the packets, whether it is interested in that or not. So the packet will be processed in many layers. So in the layer 1, the packet will be received. In layer 2, layer 3, layer 4. So in any of this layer, the packet will be discarded, okay, based on some conditions. So unnecessary processing will be going on. So memory will be wasted in a particular host. The processing time, okay, that means the CPU time will be wasted. Okay, so these are all, so the overall performance of your network may go down. So even by using the broadcasting, there are some types of attacks are going on. Okay, security threats are available. So these are all the drawbacks, okay, technical things, the drawbacks of broadcasting concepts. Now, I'm moving to the next one, types of broadcast addresses. So if you take broadcast addresses, there are 4 different types available. Okay, so we are going to discuss what are they one by one. We will discuss in the coming slides. So before that, you take any IP address, okay, IPv4 address or IPv6 also you can take. We can divide the addresses into 3 parts. So there are 3 different parts available in a IP address. You can break the IP address into 3 different things. So first one is the network ID. Second one is the subnet ID. Okay, that means subnet ID part, and this is the host part. So you know about the subnet mask. Okay, so based on the subnet mask, we are dividing this into 2 parts, network part and host part. Now I'm including one more thing here, which is the subnet ID. Okay, so an IP address can be divided into 3 parts. So the first part is the network ID, second one is the subnet ID, and third one is the host ID part. Now I'm having an example here. So 130, 245, 224, 19. So this is the IP address given to me. So this is a class B IP address because it starts with 130. So I'm dividing this into 2 parts. Okay, you can see the first 2 octets, we can say. Okay, the correct word is octets. So the first 2 octets, okay, I'm going to say it is a network ID. Then the third and fourth octet, again I'm dividing into subnet. That means we borrowed some bits. In the third octet, some bits have been borrowed here. So this is going to be the subnet ID. Then the last octet is the host ID. So IP address can be divided into 3 parts: network ID, subnet ID, and host ID. So based on this, now we are going for the types of broadcasting addresses. Now, if you see the first type, which is the subnet directed broadcast. Now, I'm taking the network ID here. I'm taking the network ID. Then we are having the subnet ID. Then the host part, I'm going to make everything 1. So if you make all ones, okay, that means I'm converting everything into ones, binary value. So that is going to be subnet directed broadcast. Okay, you can see an example here. So 130 to 45. So this is going to be your network ID. Okay, that means the network part. And 224, this is going to be the subnet part. So we have done subnet. The remaining parts, I'm going to make it all ones. So if I make everything is 1, that means all the 8 bits, if I make it 1, so that is going to be 255. So this is going to be a subnet directed broadcast. So that means, this is a major network. The major network we divided into 4 subnets. For example, I divided this into 4 subnets. So for the first subnet, I'm going to have a separate broadcast IP address. Okay, this is. For the second subnet, we can have a separate broadcast IP address. For the third subnet, fourth subnet, okay, we are going to have separate, that means an individual broadcast IP address will be available. Now, routers will never forward. Okay, broadcast is going to be in the local subnet. It is going to be in the local subnet only. So normally routers, they are not going to forward this broadcast. Okay, so the broadcast packets, okay, the routers are not going to forward it. We can see in the next slide. Okay, so routers will never forward any broadcast packets. So it will just drop or it will stop the broadcast packet within the network itself. Okay, I think you might have studied about broadcast domain. Okay, broadcast domain. So the routers, for every interface, it is a broadcast domain. So the broadcast will take place only in that particular network. Then most commonly used broadcast addresses. So whatever it is, any broadcast packet, it will never deliver. Okay, that means the router will stop the packets. Now you can see here. So this is an example here. So I'm having a router. So this is a router. Okay, this is a router. I'm going to have a broadcast packet. Okay, that means the destination IP address of the packet is a broadcast IP address. Okay, you can see 192.168.42.255. So this is a packet with broadcast IP address destination. So the packet is reaching the gateway. Okay, that means the router. So the router, okay, will never forward this packet. So it will drop the packet. Suppose if it is allowing the packet, what is going to happen means, so it may create some types of attacks. Okay, denial of service attack, amplification attack. Okay, in security you might have studied about all these things. So routers will never forward. Okay, suppose if it is forwarding means the entire network will be down. That means internet. The entire internet will be down. Okay, because of the broadcast packets. So the broadcast packets, it will be stopped by the routers. Now I'm moving to the second type of broadcast address, all subnet. So what is all subnet broadcast means? Okay, so for example, I'm having a major network. So this is a major network. So the major network I'm dividing into 4 subnets. So what we discussed in the previous slide in 5.1, what we discussed means we discussed about the broadcast IP address for a particular subnet. Now we are discussing about the second type of broadcast address, which is all subnet. Okay, that means for all the subnets, okay, we are going to have a common broadcast IP address. So how we can make it? You can see network ID. This is the first part. Then we are having the subnet ID. Then we are having the host part. Now, so only the network part I'm taking as it is. Okay, subnet part I'm going to make everything 1. All the 8 bits, okay, I'm going to make it 1. And then for the host also I'm going to make everything as 1. So 130, 25, 245. So this is going to be the all subnet. So I'm not mentioning first subnet, second subnet, third subnet. I just remove that. I make everything is 255. Okay, now this is going to be all subnet broadcast. So broadcast to all the subnet under a particular network ID. So almost this concept is not used. Okay, this is not okay, it is available, but this is equal to the third one, you will see later. Now, so this is never used one, may not be allowed for the administrative reasons. So because what is the major reason for making the subnet means to reduce the traffic and for the security reasons. So if you allow a all subnet directed broadcast means, so almost okay, security issues will be available. So this is not allowed, but the concept is available. Okay, it is not allowed, okay, by the administrators. Then I'm moving on to the third one. The third one is network directed. So it is both are same. Okay, you can see the previous one and this, it is almost same, but what is the concept means here I'm not doing any broadcast, sorry, any subnet. Okay, I'm not doing any subnetting here. Okay, see, I'm having network ID, this is the network part. So I'm not showing the subnet part itself. So completely the subnet part is removed. So without subnetting. So this is a major network. So for the major network, okay, I'm not showing any subnetting here. So completely a major network. For this, I'm going to have a broadcast IP address. So network part, I'm going to keep as it is. Broadcast packet, sorry, broadcast, that means, sorry, host part, I'm going to make everything 1. Okay, so without subnetting, okay, does not exist anymore in IPv6, but in IPv4 it is available. Okay, it is available in IPv4, in IPv6 it is removed. Okay, for example, so if you want to understand in a very simple way, so 10.0.0.0. So this is a major network. I'm not doing any subnetting here. Okay, so what is the broadcast IP address for this means? So the broadcast IP address for this particular network will be, so 10.255, okay, 255, okay, you can make it all 255s. Sorry, that means 3 octets, it will be 255. Okay, so this is going to be the broadcast IP address for this network. So this is network directed broadcast. Okay, network directed broadcast. Okay, now, so I'm going for the last one, the fourth type of broadcast address, so which is all, that means limited. Okay, limited broadcast. Okay, so limited broadcast means all the 32 bits of an IP address. Okay, you can see this is the first octet, this is the second octet, this is the third octet, fourth octet. So all the octets, that means all the 32 bits completely, I'm going to make everything is going to be 1. So this is equal to 255. So this concept is a limited broadcast concept. So older form of subnet directed broadcast. This is a older form, but still people are using this. Okay, this is an easy way to do the broadcast. So broadcast to the local subnet, never forward across the routers. So these packets will never cross the router. So your router will completely drop these types of packets. So what we discussed means we discussed 4 different types of broadcasting addresses. Okay, so this is now moving on to the next concept, broadcast and IPv6. So we already discussed about this. So in IPv6, okay, the broadcast concept has completely removed. So instead of that, okay, they use multicast for most of the applications. Okay, whatever available in in broadcasting concept, any application, whatever the application available or working based on broadcasting, it is now moved to the base, okay, multicast. So multicast, which also serves as a better alternative to the broadcasting in IPv6. So this is the concept of IPv6. IPv6 supports only three things. One is a unicast, multicast and anycast. Broadcasting is not supported. Okay. Now we are going to have an example here, unicast example of a UDP datagram. Okay, you can see the words very carefully. Unicast. So generally unicast means we used to think about TCP protocol, but here I am going to take unicast example of a datagram protocol or a UDP datagram. So using the UDP protocol, how the unicast is taking place. Now you can see. So there are three machines available. This is the first machine, this is the second machine or second host, and this is the third host. So there are three different hosts available in this network. Now I am going for the first host. So I am going to prepare the data. That means I am going to fix the destination IP address is 192.168.48.42.3. So this is a unicast, that means a IP address. Okay, I am fixing a unicast IP address. Then this is the port number, 7433 is the port number. So the data, it is moving to the next layer. So it is a UDP. So here the port number will be added. Then it will move on to the next layer. Okay, here the IP address, source IP address and destination IP address will be added. So that means encapsulation is going on. Then it is going to move on the next layer. Okay, so in layer 4 it is called the segment. Layer 3 we are going to call it as packets, that means the protocol data unit, PDUs. So here we are going to say it is segments, and in the IPv4 we are going to say it is a packets. Then in the next layer we are going to say it as, okay, frames. Now you can see this is a frame. So your frame is completely ready. So this is the data, your data, that means whatever the message or the data that you want to send. Then in the UDP layer, so that means in the transport layer, layer number 4, okay, port numbers are added, destination port number is added, source port number also will be available, but we are just focusing only on the destination, not on the source. Now the next layer is the IP layer. So here, okay, we are having the destination IP address. So destination IP address 192.168.42.3, but I am using the protocol which is the UDP protocol. Then come to the next layer, that is the layer 2 information. So this is the data link layer. So here usually the MAC address will be available. You can see the MAC address, destination MAC address, a particular MAC address I am giving here. Okay, so that means the MAC address of this last machine. Okay, the MAC address of this last machine. Okay, so I am fixing a particular MAC address. That means a clear MAC address we are fixing. That means we are not giving broadcast MAC address here. Then this is the type of the frame. Okay, 0800 is the type of the frame. Okay, now so the frame is ready now. Okay, so it is now ready. It is going to move on in the network. Now, so the packet is moving, okay, from the first machine to the second machine. If you use unicast, okay, with TCP, okay, if you use unicast with TCP, so directly the packet will reach only the destination. Okay, we know the clear destination, this is the destination. But now what I am doing means I am using the unicast with UDP I am using. So if it is a UDP means, so it is going to work similar to the broadcast. Now, so the packet will reach the host which is available in the middle. Okay, it is going to reach the host available in the middle. Now your the packet is going to reach in this place. Now the middle host is going to compare the MAC address. Okay, for example, so this is my MAC address. Okay, let me take it only the last, okay, two numbers, 38. So this is my MAC address. The MAC address available inside the frame, okay, inside the frame it is going to be B4. So this B4 and 38, okay, it is not matching. Okay, or just take complete. So this is my MAC address. The destination MAC address available in this packet is not matching with me. So this frame is not for me. So the middle host is going to ignore. It is going to ignore this particular frame. Okay, because it is UDP. Suppose, just assume there is one more host available in this place. Okay, one more host available. Now the packet will reach that particular host also in the data link layer, that means in the layer 2. So it will check the MAC address. If the MAC address is not matching, okay, the frame will be dropped. Now go to the last host. So here in the last host, the frame will be accepted and it is going to check what is the MAC address. So my MAC address is B4. Okay, the MAC address available in the frame is B4, so it is matching. Okay, then it will pass on to the next layer. So in the next layer, okay, this machine is going to check the IP address. So my IP address is 192.168.42.3 and the IP address given here, it is matching with me. So it is going to accept, then it will be delivered to the next layer. So in the next layer, okay, the port number will be discussed. So 743, so here 743, so it is matching, the packet will be accepted. So what you are understanding from this means, if it is a unique, you are doing unicast now, but by using the UDP. So in the case of UDP, okay, the packet will be delivered to all in the network, but the packet will be dropped. Okay, it will be dropped in the layer 2. So this is what we are understanding from this particular example. So in the next 2 slides, so the explanation is giving, okay, it is given, okay, you can just go through it easily, you can understand, okay, whatever I explain. Now I am going for the next example. So what is the next example means, you can see unicast versus broadcast example on UDP datagram. Okay, so the main thing is broadcast example, okay, on a UDP datagram. So in the previous slide we discussed about the unicast example. Okay, unicast example on a UDP datagram we discussed, but now I am going for the broadcast example using a UDP datagram. So almost the concept will be similar, but there will be some few changes in the IP address and MAC address. Now you can see there are 3 hosts available. So this is the first one, the first host. Okay, so this is the first host. So this is the second host. Okay, the second host, and this is the third host. So there are 3 hosts available here. Now we are going to start from here. Okay, so our concept is broadcast. Now, so a packet is getting ready, some data. Okay, it is going to be ready in the application, that means the sending application. So the data is going to come to the UDP layer. So UDP layer, it is the segments. Okay, it is going to add the port number. You can see here the data is ready. It is going to add a port number. So here I am going to use a port number, destination port number 520 is the destination port number. Then the next layer, that means segment is now moving to the next layer. So in the next layer, okay, it is going to add the IP address. So here what type of IP address will be added means we are now doing the broadcast. So broadcast IP address will be added. Okay, now you can see 192.168.42.255. This is the broadcast IP address. Okay, 255 ends with 255. It is a class C IP address. So this is a broadcast IP address. Now the broadcast IP address is added in the packet. Then, okay, it is going to move on to the next layer. So the next layer is the data link layer. So here we have to include the MAC address, but the MAC address is also, it is going to be a broadcast MAC address. What is broadcast MAC address? Okay, you can see all F. This is a broadcast MAC address. That means the length of MAC address is 48 bits. Okay, the length of the MAC address is 48 bits. So all the 48 bits will be, okay, it will be fixed as ones. That means 111. All 48 bits, it will become 1. That means the binary value. So if you convert into the hexadecimal value, so it is going to be F. Okay, you can see. So all 48 bits made it 1. So this is the broadcast MAC address. So this is going to be a broadcast MAC address. So your frame is ready. Now the frame is coming, okay, it is going to reach, okay, you are delivering, that means the first machine is sending the frame in the network, okay, so the frame is going to reach the machine which is available in the middle, okay, it is reaching here. Now here in the data link layer, so simply they are going to accept the frame. So why it is going to accept the frame means because it is going to check the MAC address. The MAC address is a broadcast MAC address. Okay, the MAC address is a broadcast MAC address, so it will be accepted. Okay, it will be accepted. So there is no question here. So the middle host, it is going to see what is the MAC address of the destination MAC address of the packet. So the destination MAC address is all F's. That means it is a broadcast MAC address. So automatically the packet will be accepted and it will be sent to the next layer. Now in the next layer, that means in the network layer, so the host is going to check what is the destination MAC address, destination IP address. Now if you see the destination IP address, it is 192.168.42.255. So this is a broadcast IP address. So there is no question now. My IP address is 2. Okay, that means 192.168.42.2. This is the IP address of this machine. But still it is going to accept because it is a broadcast. Okay, the destination IP address is a broadcast IP address. So the packet is accepted here. Now it will be given to the next layer. So in the next layer, I am going to check the protocol. That means the port number. So my port number is going to be a different one and the destination port number is going to be a different one. So it is not matching. So the packet is discarded in this particular place. Okay, so this is what happening in the middle machine. So if you go for the last one, it is going to accept everything. Okay, so the frame is accepted because the frame is having a Ethernet MAC address. Then in the IP layer, the packet is accepted because the packet consists of a broadcast IP address. Then in the next layer, that means in the transport layer also, the packet will be accepted because the port number is matching. My port number is 520. The destination port number available in the frame also it is going to be 520. So 520 it matches. So automatically the packet will be accepted and it will be given to the application layer. So this is how the broadcasting is working on a UDP. So what we are understanding here means, so the packet will be processed in many layers here in the middle machine. If you see, the packet will be processed many layers, then finally in any one layer it will be dropped. Okay, so we are accepting the packet in the level 1, that means the layer 1 physical layer we are receiving. In the data link layer it is processing, accepted. Then in the IP layer, that means in the network layer the packet is processed. Then the packet is again processed in the transport layer. So in the transport layer only, the packet is dropped. So what we are understanding means it is a waste of time. So your processor time will be wasted. The memory will be wasted. So network, that means network delay will be there. That means it is going to consume the bandwidth. So this is going to be how the broadcast is handled in a network. So this is a concept. So they are explaining this concept in the next slide. So this one slide they are explaining what is this. Now the next topic is problems with broadcasting. So I think no need to repeat again and again. So whatever we discussed in the previous slides. So one will be the bandwidth issue. Second one, it is going to consume more memory. It is going to consume the CPU, then the processing time will be wasted. So these are the major drawbacks. Suppose if you allow the broadcast packets in the internet, so the completely internet will be it will be it will be closed. It will be down, we can say the correct word. So because broadcasting packets, if one router is allowing a broadcast packet, means it's completely, then the internet will be down. In few minutes it will make the internet down. And also one more important point, the broadcasting packets or the broadcasting concepts is used by the attackers. So many attacks, like denial of service attacks, flooding attack. There are so many different types of attacks possible by using the broadcasting concept. So there are a lot of disadvantages available. Now I'm going for the next one. The next one is how to enable the broadcast concept in a socket. If you are writing a socket program, so either in C or C++ or Java, in Python, whatever it is. So if you are creating a socket, means you have to specify that particular socket is a broadcast. So I am going to talk about only in Java. So in Java we are having an option called SO_broadcast. So by using this concept, if you enable this particular concept, so that particular socket, it will be specifically, it will enable the broadcast. Otherwise, that socket will not do any broadcasting. So that means you have to inform the kernel. You can see we are not allowed to send a datagram to a broadcast destination address until we explicitly tell the kernel by setting this particular option. So you have to fix this, otherwise it will, you will get the error like permission denied. I will show you a piece of program, a program segment, you can understand, you can see. So this is a program written in Java. You can see so_broadcast. So this particular socket is going to be allowed. Okay, this socket is allowed to do the broadcasting concept. Okay, so with this we are completing this particular lecture. So the next lecture is going to be the multicast concept. Okay, thank you very much. Keep watching.